go. There we go. Okay. So today we're getting into chapter 4. This is all about trigonometry. I'm going to let you know right now, while last chapter I liked decimal answers and say you do not need to leave things in their exact form, because honestly, I want you to get an idea of how the logarithms are working. With trigonometry, we want to leave everything in the exact form. So if I say, like, I want the sine of pi over 4, if you give me the decimal for that, I will not recognize that. But if you tell me it's root 2 over 2, I instantly recognize that. And we'll get more into that. So let's start. What is trigonometry? Trigonometry is the measurement of triangles. The central angle of a circle is an angle whose vertex is at the center of the circle. If I talk about complementary angles, those are angles that add up to 90 degrees or pi over 2 radians. If I talk about supplementary angles, they add up to 180 degrees or pi radians. Degree is a common measure for angles, but we will actually be focusing more on radians. So degrees, you guys have an understanding of those. That's how we've measured angles your whole life. Radians, however, is this unit that is actually based on a much more mathematical sense, and is a unit that pretty much most math you do from this point on will actually talk about radians more than degrees, with the exception of some physics like still working a lot in degrees, just because it is a more commonly used unit. But a lot of the math, like there might be a quick conversion to radians to do everything, then go back. Okay. So just some vocabulary here. An angle is determined by rotating a ray about an endpoint. The initial side here in green is the starting position. The ending side or terminal side is the position after the rotation. And the vertex is that endpoint of the ray. And the angle is in standard position when the initial side is the positive x-axis. A lot was said there. Look, we're going to utilize this enough. Basically, I want all my angles by default to start with the positive side of the x-axis, and we'll grow from there. So positive angles move in a counterclockwise way. So when I talk about angles, if I have my plane here, right here, this angle, that's a positive angle. Down here in green, if I go this way and moved like this, that one would be a negative angle as I'm moving in a clockwise manner. If two angles are coterminal, they have the same initial and terminal sides. So if I really wanted, I could make an angle that's negative like this, and it would be coterminal with the blue line, just due to the fact that they both end at the blue line. Okay. So the measure of an angle is determined by the amount of rotation from the initial side to the terminal side. 1 radian is the measure of the angle equal to the arc length S is equal to the radius R. Okay, so that's kind of a very, very formal definition of what a radian is. Here's what radians are. I'm going to break it down a little more. So radians pretend, the idea of a radian comes from, let's pretend a circle has a radius of 1. If I have a radius of 1, I know that all the way around, if I did the circumference, that'd be 2 pi r, or 2 pi times 1, which is just 2 pi. So all the way around is 2 pi. What radians say is, wait, can't we just measure it each time? So if I say something is so many radians, that's how far along the edge, if the radius is 1, that's how far along the circumference we travel. So algebraically, that means that the arc length, or theta, is the arc length s divided by the radius. The central angle of one full revolution counterclockwise corresponds to an arc length of 2 pi r. That's just the circumference. Ooh, 1 second, guys, sorry. The senior meeting is a Zoom meeting. You do not need to come to the school. So I did get a message about that. It is a Zoom meeting. You do not have to come to the school, even though it is during class hours. Okay, let's look at this in action. So one full rotation around the circle. My radius is 1. That would be 2 pi. 2 pi radians corresponds to 360 degrees. Pi radians corresponds to 180. Similarly, a quarter revolution would be pi over 2, or 90 degrees. If I go 1/6 of the way, that is pi over 3, or 60 degrees. We'll talk about how to convert in a second. So the angles between 0 and pi over 2 are acute angles, just like angles between 0 and 90 are acute angles. Angles between pi over 2 and pi radians are obtuse, just like angles between 90 and 180 are obtuse. Okay, so find the angle that is coterminal with this. Excuse me. So if I want to be coterminal, I'm either going to have to add or subtract 2 pi. So when I add 2 pi, I go all the way around counterclockwise. When I subtract 2 pi, I go around all the way, clockwise. So here with this, so find an angle coterminal to this. All I'm going to do is add pi over 2. Now, if you give me a decimal here, I am just going to mark it wrong. A decimal will not make much sense to me here. I don't know where that is approximately. I'm looking at this as how I divide up my circle. So I want to add pi over 2. Now, this will require you to add some fractions. I want a common denominator of 8, so I can actually say instead of pi over 2, I can add 16 over 18. And when I do that, that gives me 15 pi over 8. If you gave me what the decimal 15 pi over 8 is, I wouldn't know what that is. I would not recognize that right away. That's why I need this exact answer. We're just going to leave it as 15 pi over 8. So what that is actually telling me, since my denominator's 8, so I know 2 pi goes all the way around. Okay, that would make pi, okay, 90 degrees is pi over 2. So this is like a quarter of 90 degrees. Since it's 15 on top, I know I go almost all the way around the circle. I know what I just said there. You're probably like, oh, what are you talking about? I know I went fast there. It will start to make sense as we work more and more with the unit circle, which we're getting into later today. So that's how I found that coterminal angle. All I did was add 2 pi. To find supplementary angles, they need to add up to pi. So what I want to do is do pi minus pi over 4 here. Get a common denominator of 4. So that's 4 pi over 4 minus pi over 4. 4 minus 3 is 3 pi over 4. And again, you give me the decimal for 3 pi over 4, I have no clue what you're talking about. When you tell me 3 pi over 4, I know that, oh, if I want to go to degrees, that's 135 degrees off the top of my head. So that's why I want these exact answers here. Please do not put these in the calculator and give me a decimal. I do not want that. Let's see, any questions so far? Let's go here about converting. So here are our formulas to convert from one to the other. So what a full revolution counterclockwise around the circle comes out to be 360 degrees. Half a revolution is 180. Well, since half a revolution corresponds to just pi, that means that if I do my degrees times pi over 180, that will convert to radians. If I have radians and want to convert to degrees, I flip that fraction around. So a lot of times when we go radians to degrees, we'll have pi actually cancel out. And that will be fine if it ends up needing to be a decimal, putting degrees as a decimal, putting radians as a decimal though, big no-no. We do not want to put radians as a decimal. We want them as exact answers every time. So let's take a look. Those are our formulas. Let's see, this says to convert. Oh, I am sure. Oh, let's do that instead. There we go. So convert 120 degrees to radians. This is a measurement I will ask you to have memorized, but we're going to go through it right now. So that'd be 120 times, almost wrote it backwards, pi over 180. So here's what we're going to do. Just going to multiply. I'm going to say 120 pi over 180. Let's see, both those numbers are divisible by 60. So I reduce this, and this reduces to 2 pi over 3. So this is just 2 pi over 3. Now, if you're having trouble reducing fractions, Desmos can be our friend here, so I don't want to put the pi in it. I'm just going to put the whole numbers. So I did 120 divided by 180. That gives me this decimal. I don't want a decimal. I click right here where the little fraction bar is, and it turns it into a fraction. So, oh, that reduces to 2/3. So if there's a pi hanging out in the numerator, that's 2 pi over 3. Okay, convert 9 pi over 8 to degrees. 9 pi over 8 times 180 over pi. The pi's conveniently cancel, leaving me with 9 times 180 over 8. Now, honestly, here, I just see this. This is just going to be easy to put in the calculator. So 9 times 180 divided by 8. Whoop. And that gives me 202.5 degrees. Degrees, absolutely fine as a decimal. We're used to that unit. And that is how we will write that unit conventionally. So 22.5 is just our answer here. So not too much more than going past 180. And again, once you get more familiar with the unit circle, you're going to be able to see that with just being 9 pi over 8, you'll be able to actually get an estimate of where that is. So look, I'm not going to take the time to do the conversion on each of these, but I will tell you what these are. These are very common degree to radian conversions that you should have memorized. I know you don't have them memorized now. You just need to memorize them. 0 degrees, 0 radians. Pi over 6 radians is the same as 30 degrees. 45 degrees is pi over 4. Pi over 3 corresponds with 60 degrees. 90 degrees corresponds with pi over 2 radians. Pi radians corresponds with 180 degrees. 270 degrees corresponds with 3 pi over 2. So again, these are just common conversions. I do hope you take the time to learn. Okay. For a circle with a radius r, the central angle intercepts the arc as so. So note, if the radius is 1, that just means that the arc is the same as the length. So the angle is the same as the arc. S is the arc length, so when the radius is 1, our angle theta is the same as the arc length. Okay. So here with this, consider a particular movement at a constant speed on a circular angle r. If S is the length of the arc traveled there, so when we talk about linear speed, we're going to do arc length divided by time. When I talk about angular speed, we're going to do the angle divided by time. So a 6-inch diameter gear makes 2.5 revolutions per second. Find the angular speed. So angular speed only deals with how fast the angle's moving. Since it's angular speed, that diameter means nothing in here. Sorry, your screen's about to go gray for 1 second. So diameter 6 inches doesn't mean anything here. 2.5 revolutions. So it what's in radians per second. So I'm going to do 2.5 times 2 pi radians. So that means I go 5 pi radians every second. So your homework is right here on page 261 to 262, 25 to 28 all, then 43 through 54 all. This is your only homework, 2.2. I do not give a formal homework assignment 2, but I will ask you to move or to work on memorizing the unit circle. So let's now go into the 2.2 notes on the unit circle. So as the real number on the number line wrap around the unit circle, each point corresponds to a point on the XY plane. So actually, let's look at the unit circle before all this. So here's what's happening here. This is the unit circle. I can set this value to whatever I need it to be. So there we go. I can drag this point. We notice we keep this orange, green, and purple triangle, but as I drag this around, this XY point is constantly changing. So I can just keep it going around. Trying to get it, it's not falling on an exact value, but we can actually try and stop it on more precise values and actually find like the sine and cosine values and see how they correspond. So when I talk about the unit circle, I'm talking about the full set of points that are created right here. Each angle T corresponds, or each real number T corresponds to that in their position. The length of the arc is the same as the radians since we make the radius 1. So because the radius is 1, whatever this arc is, or whatever this angle is in radians, is the same as this arc length right here. Okay, so talking about our trig functions, we have sine, cosine, tangent. You've seen those before. Sine, cosine, tangent, you're probably pretty familiar with their abbreviations. We also have cosecant, which is the inverse of sine. We'll get into that more, but that is abbreviated the following way: secant, SEC, and cotangent, COT. So each of these, so like if I want to know what secant is, I take the reciprocal of cosine. Cotangent's the reciprocal of tangent. Cosecant is the reciprocal of sine. I know I'm moving a little fast here, just trying to get everything in. So when we talk about the unit circle, if we want sine, sine is just our y value. If you notice here, if you recall, sine is always opposite over hypotenuse. So if I'm at this angle in here, green is opposite that. Green is my y value, so that's sine. My orange right here, that would be cosine. So x values correspond to cosine, y values correspond to sine. Tangent would be y over x because tangent is defined as sine over cosine. Cotangent is the reciprocal of that, so that's x over y. Thank you. Secant is the reciprocal of cosine, so that's 1 over x. Cosecant is the reciprocal of sine, so that's 1 over y. So that is that. Okay. Here with this comes from the unit circle. So, here. Okay, let's see here. We're going to try and stop it at particular values. So at 0, there we go. We had the point 1, 0. That's my x, y values. If I go to pi over 4 is located, come on, snap to it. There we go, right here. If I put in the 2 to the 1/2 power, so the square root of 2 divided by 2, I get that same xy value I have here. So that's root 2 over 2 when I'm at pi over 4. When I get to pi over 2, come on. That's right here. 3 pi over 4 would be right around here. So the x is negative, y is positive. Get to here. That's pi radians, -1, 0. 5 pi over 4 should be right around here. Come on, snap to it. Okay, it's not liking to snap to that point right away, but again, I'm really close to it. We see both are negative. And again, I can just keep going around here. So these are all critical values to memorize. So at my something pi over 4, I'm going to have either positive or negative root 2 over 2. When I'm at pi's, I get 1, 0 or 0, 1, or sorry, -1, 0 or 1, 0. If I'm at pi over 2's, that's 0, 1 or 0, -1. Over here, again, I'm not going to go with the full breakdown of it, but it kind of corresponds to just what we were doing. If I want to go to pi over 6, that's 30 degrees. That's right here. And we get our y value is 0.5, so that's the same as 1 over 2. And if I put root 3 over 2 in the calculator, we get 0.866. So here with these are these values. Honestly, it's going to be easier to work on memorizing off of the unit circle. Whoop, these are already done. Okay, let me quickly erase this part of them. I just want to quickly go over how we do these. Okay, so if I want the cosine of pi over 3, I'm going to go back to my table, or actually I'll show you the unit circle. Pi over 3 is here. Cosine is my x value. So I just looked at the x value on this, that's 1/2. So the cosine of pi over 3 is 1/2. Tangent is y over x. So I want the tangent of 4 pi over 3. So 4 pi over 3 is located right here. My y is root 2 over 2. My x is negative root 2 over 2. So I'm just going to put those in fraction. Over 2 over negative root 2. Send me a screenshot of that and I'll figure that out, what's happening there. Those cancel out, essentially just giving me -1. Okay, cosecant. of 7 pi over 6. So that's 1 over the y value. So 7 pi over 6 is down here. The y value is -1/2, so I want to do 1 over that. So that's 1 over -1/2. So it's going to be 1 times 2 over -1, which is just -2. Okay. So talking about domain, range, period. So period is how long it takes something to repeat. So the period for both sine and cosine is 2 pi. The domain and range for the domain for both of them will be all real numbers, whereas the range, -1's my lowest value, +1's my highest value. If you notice, as I drag this around, these XY points never go below -1 or above +1. They're all trapped inside between -1 and +1. That's why the range is like that. So if we're talking about even and odd functions, cosine and secant are even functions, and the others are odd. Hello. Yes, I do. Yep. Perfect. You're welcome. They're ready for you down in the cafeteria for your shot. Yeah, I would. Okay. I left these here too. Oh, I forgot to erase them after I did all this. Okay. So here with this, I want to evaluate the sine of 31 pi over 6. In order to do that, I need to get this between 0 and 2 pi. This is definitely bigger than 2 pi, so I'm just going to keep subtracting out 2 pi till I find that angle that is coterminal with it. So I can do 31 pi over 6 minus 2 pi. Well, that's the same as 31 pi over 6 minus 12 pi over 6. 31 minus 12 is 19 pi over 6. Unfortunately, I realized 19 pi over 6, it's still bigger than 2 pi because 19 is more than twice as much as 2, or twice as much as 6, sorry. So I'm going to subtract another 2 pi. So that's really just 12 pi over 6. 19 minus 12, that's going to be 7 pi over 6. So since those are coterminal, I know the sine of 31 pi over 6 is equal to the sine of 7 pi over 6. I know sine corresponds to my y values, so I'm going to look at my unit circle. 7 pi over 6, my y value is -1/2. Whoa. -1/2 down here. So that's what my sine value is. That's just -1/2. Okay. So here with this, to evaluate secant, we could just type in the word secant, or the abbreviation for secant, or do 1 over cosine. To evaluate these in the calculator, these are in radians. Now, these said to evaluate in the calculator, so decimals are okay here. So I want to make sure I'm in radians. To do that, we hit the wrench up here. I see radians is highlighted, so we're okay. So I can just be like the tangent. So tan, if you don't feel like typing it.
All right, ladies and gentlemen, we are about to move to our block 2.
They're right here.
By the main office.
Or sorry,
Mr.
right
Myers,
here.
you're walking through the hallway. Right, you're walking through the hallway. Make sure your nose and mouth are covered at the same time. You're walking one direction only. And if you need to use the other, it's one.
So there's that decimal answer.
Outside, and class is missing. Center 3, room 327. 327.
And that's the other one. Okay, so I need the chapter or the section 1 homework done hopefully tonight. Tomorrow I will go over how to read the unit circle and working on memorizing it. So that's going to be the focus of tomorrow. So guys, thank you. Have a great day. I'll make sure to get this up. I know this was cut just a little bit short, but we'll get it all done. I do know a few people showed up a little late, getting your attendance in now. Stop recording.